Now in the previous lectures I go through the partial fraction, the definition of partial fraction, and the definition of proper fraction, improper fraction, and compound fraction. And the basic point in the partial fraction is that we can apply partial fraction tools only on proper fraction. If someone gives us improper fraction, then we can't directly apply the partial fraction tool, because first we have to change that fraction into proper fraction, from improper fraction to proper fraction by long division method. Then after that we have to find its partial fraction. So the first case of partial fraction is first case of partial fraction. If the denominator of a proper fraction consists of linear non-repeated factor. For example, p of x is a fraction and q of x is consist of x minus a into x minus b. This is a proper fraction and denominator consists of linear non-repeated factor. Then we will split this fraction as in first case with a divided by x minus a plus b divided by x minus b. And after that, in the second step, this is first step, and the second step we will multiply the denominator on both sides of this equation. So multiplying, now this is second step, multiplying x minus a into x minus b on both sides of this above equation. So p of x divided by x minus a into x minus b, a divided by x minus a into x minus a into x minus b plus b divided by x minus b multiplied by x minus a into x minus b, multiplying x minus a into x minus b. So this is the second step, multiplying the denominator on both sides of this equation. In the first step we will split the fraction in this way if it consists of linear non-repeated factor, and the second step we will multiply the denominator to both sides of this equation. So x minus a will be cancelled out with this x minus a, x minus b will be cancelled out with this x minus b, and the right hand side will only be left with numerator p of x, and x minus a will be cancelled out with this x minus a. So where a will be with x minus b plus b, x minus b cancel out with this x minus b, so b will be left with x minus a. This is the end of second step, end of second step. Now we have to find the root. So in the first, this is the beginning of third step. In the third step we have to take this and assume that this is equal to 0, so shift this minus a to this side, so x equal to a. So now in the third step put x equal to a, this will be equation 1, so put x equal to a. So p of a is equal to a into a minus b plus b into a minus a, 0. A minus A is 0. So B with 0 is 0. So A is equal to P of A divided by A minus B. This will be the value of A, and we will put it in here in the place of A. Now in the third step, now put x minus b is equal to 0. So x equal to b. Now put x equal to b in equation 1. So P of b is equal to A into b minus b plus b into b minus A. So this is 0. So b is equal to P of b divided by b minus A. Capital B is equal to P of small b divided by b minus A. So this is the value of A and this is the value of B. Now put the value of A and B in this expression, this equation. So A is equal to P of A, put in the right side. So P of A is equal to P of A divided by A minus B into x minus A, plus B is equal to P of B divided by x minus B. P of B is equal to P of B divided by B minus A. So this side is equal to this side in this way. So this is the first tool, the first case of partial fraction. And if the roots are non-repeated linear factor, then we will apply the partial fraction rule on this way. So let's take another example. Now for example, we will use another practical example, which is 1 over x cube minus 1. This is a function. Let this is a function f of x is equal to 1 over x minus 1, x cube minus 1, or x square minus 1. This example is easiest, so I take the another example, which is f of x is equal to 1 over 2x minus 1 and to x plus 1, and find its partial fraction. So 1 over 2x minus 1 and to x plus 1, a divided by 2x minus 1 plus b divided by x plus 1. This is first step. And the second step, we will multiply the denominator, which is 2x minus 1 into x plus 1 on both sides of this equation according to the second step. So 1 will be equal to a into x plus 1 plus b into 2x minus 1. This is the second step. Now in the third step, let 2x minus 1 equal to 0, then 2x is equal to 1, x is equal to 1 over 2. Put x is equal to 1 over 2 in this equation. So put x is equal to 1 over 2 in this equation. This is equation A. So 1 is equal to a into 1 over 2 plus 1 plus b into x is equal to 2 into 1 over 2 minus 1. So this will be equal to 0 because 2 will be cancelled out with this 2. 1 minus 1 is 0. So 0 into b is 0, which is nothing. So 1a into the LCM of this, we can 1 plus 2, which is 1 is equal to a into 3 by 2. So or this implies that a is equal to 2 by 3. Now put x plus 1, let x plus 1 equal to 0. So x is equal to minus 1. So x is equal to minus 1. So put x equal to minus 1 in this equation. So 1 is equal to a into minus 1 plus 1 is 0. So b into minus 2 minus 1, which is b, into minus 3 equal to 1. So b is equal to minus 1 over 3. So this is the value of a and this is the value of b. Now put the value of a and b and this equation. So 1 over 2x minus 1 and to x plus 1 is equal to a is equal to 2 by 3 into 2x minus 1 plus b is equal to minus 1 over 3, which is minus 1 over 3 into x plus 1. So 1 over 2x minus 1 into x plus 1 is equal to 2 divided by 3 into 2x minus 1 minus 1 over 3 into x plus 1. This is the splitted fraction of this fraction. So the denominator is consist of linear non-repeated factor. This is the first case. In the next video we will talk about the second case, which consists of linear repeated factor. If the denominator consists of linear repeated factor, so if the denominator consists of linear repeated factor, then it will be the second case of partial fraction, and we will proceed it in the next lecture.